We have looked at a couple of different things that we do with numbers, how to make numbers work with units, how to convert them from one thing to another. And we are now at the point where we want to actually do something with these numbers, use them for something. So we are going to talk now about modeling. Modeling is a useful skill in physics, and the idea is pretty straightforward. You're going to take a complex scenario and more or less say that is a lot like this simple thing so that you can solve it. So you're taking something that you don't know how to solve and breaking it into pieces that you do know how to solve. One of the more common applications is with shapes. So maybe you're doing a biomechanics problem and you need to figure out what happens when a human body is subjected to these forces at those locations. The human body is a little bit too complicated of a shape for me to want to do much math with, so I'm going to make some simplifications. Here is a person standing. The torso, it's pretty much a cylinder, right? So I'm going to say here, torso is a cylinder. The head sounds like a sphere. And if this problem doesn't involve bending at the elbows or knees, I'm going to model the arms as cylinders and the legs as cylinders. Let's see what I've made. For the problem I'm doing, this is likely a good enough approximation. I don't have to figure out the particularly complicated case of a person. I can instead look at the shape that I've made, and the math will be a lot easier. He's probably not going to be asked to act in Jurassic Park, not this guy, but the idea is going to be similar, and the math is going to be close enough. We do this with other situations too. Maybe I am throwing a ball. So if I throw a ball, I have all sorts of things that happen with this. The ball goes through the air, but the ball is rotating. It's interacting with gravity. It's interacting with the air. Along the way, it's going to squish out just a little bit. Just because of those shapes, that's going to make it wobble. But I can say that this should behave qualitatively just like a very hard ball, maybe a point mass even, being launched like this. Yes, the actual ball will probably end up doing something like going up, coming down, and it won't be a perfectly symmetric shape where this ball is going to land like that. It's not the same situation, but it's close enough. The air resistance and the other factors, they're going to change what the actual landing place is just a little bit, but again, close enough. We do this with all kinds of things. A tendon that stretches will behave a lot like a spring, as long as you don't stretch it too far. An elbow that's supported by a bicep isn't going to be qualitatively very different from a bar that's being held up, so that's pivoted here, hinged here, and being held up by a cable. We're taking a situation and saying that this complicated thing is a lot like that simple thing, and I know how to work with that simple thing. It's not going to be perfect, but a good model will get you pretty close.